Greetings and welcome, friends. Wow, we just came back from vacation. It was beautiful weather here. The snow has melted, which I celebrated. But here we go. We're going over geometry. I think we talked about relationships between pairs of lines and angles. And let's see if we can figure out some of those relationships. So it says, name a pair of parallel lines. Anyone got some suggestions there for us? Yeah, Emmett, I see. I don't know if that's or no, you're brushing your hair. All right. MK and LS, accurate. Yeah, man, I've got to make sure I associate the letters to the correct point. So yeah, MK, and they said lines, so we'll use the line notation. MK is parallel to LS. Classic, and the reason we knew that was because they had the little double arrow, or arrow notation. I can't assume that about PR because it was not labeled such. Name a pair of perpendicular lines. Right, that's the little box angle there. Let's see, none of these lines have names, just their points, so we'll name them by their points. So how about NP? No problem. Is perpendicular to PQ. And those happen to have an intersection at point P, which we determined that when two lines intersect and they're not the same line that they intersect, blah, 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 blah. All right, there we go. So 9 is PN parallel to KM. PN to KM. No, KM? KM is this one. All right, so this one and this one. No, because they intersect. Right? No. They intersect. Bam. Guys, I remembered how to write over vacation. This is so great. They do say that writing is like riding a bicycle. Writing bicycle? I did it. No, actually, sadly, this is the longest stretch without having a day off. Other than in Vermont, we've got town meeting day. But other than that, February to April vacation's the longest stretch of school. So I'm going to say no. In my lack of knowledge, no. So let's see. Is PR perpendicular to NP? No. Because it intersects at PQ and there can only be one line, right? Or intersects at P and PQ is perpendicular and there could only be one line that's perpendicular at that point. So that's basically my verbal explanation. All right, let's see. I've got, we're not going to identify all pairs, just some. Corresponding angles would be like 1 and 5, right? So angle 1 and angle 5. Also be cautious, don't use the plus sign here, because plus is for numbers. We are talking about angles, so you could say 1 and 5 or 1 comma 5, something like that. Alternate interior angles. So alternate means they would be on alternating sides of the transversal, and they would be on the interior of the parallel lines. So like 3 and 6 or 4 and 5. No. But today we are going to talk about what if they were. That's what we'll be imagining today. So these ones are not, so we could imagine that there's probably some intersection way out that way. Is based on my perception of this. That's also a sad looking 6. There, I don't know. Alternate exterior would be like 1 and 8 or 2 and 7. Angle 1 and angle 8. Consecutive interior would be the same side as what the consecutive piece means of the transversal. So that'd be like 3 and 5 or 4 and 6, right? So you guys are golden at this, right? This was all just vocabulario. Yeah. All right. How about this? 15. Someone help me out here. Classify the angle pair. Angles 5 and 1. Yeah, those are corresponding, as far as their relative intersections, they are in the same direction, right? Northwest quadrant of their intersections, those are corresponding. They're in corresponding positions. So I'm sorry, what was your question or They're in the interior of these interiors. Yeah, so like that's what's weird about like this 4 intersection diagram is that, yeah, what you consider the transversal and what you consider the other lines shifts depending on which 2 things you're relating. So 2 and 11 are alternate interior angles. So alt int. Actually, let me what would the relationship between 1 and 13 be? Now, what I want to point out is that we don't know. We don't have a name. One of these terms is not appropriate in describing those because these intersections are made up of lines that are not relating to each other just yet. We don't have a relationship between those, right? Because there wasn't a single transversal that right corresponded between those 2 things. I've had students sometimes say like that would be corresponding, and nah, like you could kind of assume like transitive corresponding if that was a thing. But yeah, there's not a relationship between these because these intersections are not composed of lines that are right the same. And let's see, lastly, wow, at least we had like an easy assignment over the vacay, the vaca, the cow. Copy and complete the statement. List all possible correct answers. Angle BCG. Let's shift to my nice sky blue. BCG is this angle here. And blank are consecutive interior angles. Oh, these ones are the toughest when they have the triangle drawn. And then you've got to like... Yeah, the what you're considering the transversal is different. So consecutive interior angles. This angle is on the interior of these 2, right? Interior, and it's then if AG is that transversal, consecutive would be this angle here, which I could call angle CGH maybe, or some variation of that. Is there another solution to this? Another answer? I don't think it wouldn't be on the interior of these 2 lines. So J to A? Is that what you said? Like this angle and this angle? Yeah, those ones would have been consecutive interior. They ended up limiting us to a starter, so we didn't have a choice in that. But yeah, those ones would have been consecutive interior. Let's see, FCA. So FCA is this angle. All right, which actually is a vertical angle with that one. But which angle is this an alternate exterior angle with? Well, if I was looking at these 2 lines, it's interior for those, so that's not going to work. So I'm going to have to consider, man, come on, undos. It is the exterior of these 2 lines, however. Right? And so then the transversal is going to be AG again, and an alternate exterior would be which angle? GJH. Classic. All right. So thanks for watching, internet friends. It's good to be back.